Kinematics is one of those things that a lot of people don't want to do and a lot of people don't want to learn because they think it's just a physics thing and physics students have an advantage. Luckily, I'm here to teach you how to do it very simply. In VC methods, physics doesn't go that deep. It's mainly modeling kinematic equations, which involves acceleration, velocity, and position. Now, in this pretty basic example, we have a ball thrown vertically at, I've kept it a blank, should be 25 meters per second squared, meters per second of a 30 meter tall building, and assume that gravity is 10 meters per second squared. So in this case, what we should do is illustrate what's actually happening. So I'm going to draw the building here. This building is 30 meters tall. The ball is thrown vertically at 25 meters per second. Okay, and gravity is 10 meters per second squared. Obviously, this depends on the question as well. Sometimes gravity might be said as 9.81, sometimes it might be 9.8. In this case, it's 10 because it is a tech-free question, and it's easier if you have 10 because usually the numbers work out a lot better compared to if you had 9.8 or anything like that. Now, for this type of question, what we have to do is kind of interpret all the information or absorb all the information in the question. And it looks like we've done that vertically, 25 meters per second, 30 meter tall building, and gravity is 10 meters per second squared. So firstly, we're asked to determine acceleration. Acceleration is pretty easy. It's already given to us, but a lot of people kind of overlook this because they kind of see acceleration as something different. But when something is kind of thrown vertically and there's no external forces applied to it, then the only acceleration comes from gravity. So what we can say in this case is A of t is equal to -10. And I'll just include a unit as well, which is meters per second squared. Now, I just want to reiterate that this negative sign and where your kind of relative position is dependent on what you define. So for example, in this question, I've said up is positive. I've kind of assumed that up is positive and downwards are negative. It kind of makes the most sense, right? Because upwards positive, downwards negative. So when I put acceleration, I'm putting it as negative because I want to indicate that gravity goes downwards. And you can see here, even though it has g is equal to 10 meters per second squared, just by default, it's using the positive value because, you know, it's a constant, right? So it's not going to include the negative value there. I mean, it may or may not, depending on how the question's written, but we should know that gravity as convention is negative. So this one has to be interpreted as going downwards, so therefore I've included the negative. By the way, you could include upwards as negative if you wanted to, and downwards as positive. It's up to you, right? So it just depends on how you define your question. Cool. And it's not only how you define your question, and it's also about like keeping everything constant as well. So you'll see for the next one, right? When I put v of t we should know is just the integral of a of t. And now if I integrate -10, I get -10t plus c. Now my initial velocity, I already know, is 25 meters per second. And this value here, I'm going to include as positive because it's thrown vertically upwards, right? Because I've defined upwards as positive, downwards as negative. So that's what I mean when I say you have to keep everything consistent. So in this case, velocity should be equal to -10t plus 25 meters per second. Okay, and you should see a correlation between these units, meters per second squared, meters per second, and then when we get position, it's going to be just meters. So make sure that you keep your units consistent as well. And the most common unit that's used in VC methods and just in VCE in general is meters and seconds because they are what we call SI units, or the standard units that are recognized internationally. Next question, determine the position or x of t. So in this case, it just goes one step further with velocity. So we say x of t is equal to the integral of v of t. So integrate this, we end up getting -5t squared plus 25t plus some sort of c value. In this case, what's the initial position? Well, it depends what we use as our reference plane. In this case, the reference plane makes sense to be ground. So this could be ground is equal to 0. So where do we start from? We start from here, which is 30 meters upwards. So our c value should be +30. Again, this is not the only right answer. It depends on how you define your question.